Okay, so this is a short lesson for Algebra 2. Algebra 2. Lesson 40, solving rational equations, day 2. Same thing. But we're going to solve rational equations with binomials and trinomials in the denominator. I'm going to do one example for you. These are the steps, same steps as yesterday. Okay, so here's number 1. That's going to take a little while, okay? So number 1, I'm going to stare at it while I go for it. Okay, so number 1, same thing. We have a minus 7 in the denominator of on two sides. We want this to be like a proportion problem where both sides are over one denominator. This left-hand side is not over one denominator. It's over two denominators. This is 5 over 1. This right-hand side's already okay. So, first thing I want to do, this is like saying a minus 7. Put parentheses around everything so you kind of have things organized, okay? So, I would multiply this side by a minus 7 here and also right here, okay? I'm going to skip steps now because I'm assuming you're starting to get the hang of this stuff. So, the new common denominator on the right will be a minus 7. Numerator, we have, I have a 1 here, but I want to worry about my a's first. We have negative 5 times a is negative 5a. Okay? Then we have negative 5 times negative 7 is positive 35, plus 1, positive 36. Okay? All of that is equal to the other side, which is a plus 2 all over a minus 7. Okay, now we have two fractions that are equal to each other. Now we can put parentheses around everything and apply cross products, or cross multiply. So we can multiply across first. So let's do this first. A times a is a squared, so we're basically foiling. A times 2 is 2a, negative 7 times a is negative 7a. So it's going to be, combine those like terms, it's going to be negative 5a. And we got negative 7 times positive 2 is negative 14. That's all equal to the next cross product. Negative 5a plus 36 times a minus 7. So negative 5a times a is negative 5a squared. Then we have negative 5a times negative 7 is positive 35a. 35a. Then we have positive 36 times a is positive 36a. So we combine these two and we get 71a, right? Okay. And then we have positive 36 times negative 7. Negative 252? Okay. And again, you should start using your calculator on these types of problems. Alright, now we have two sides of the equation. I want to combine everything to one side. So we have negative 5a squared. I like making it so that everything is positive, or at least the leading term is positive. This is a positive a squared, so I know that if I add 5a squared, that it's going to make it positive. So I'm going to move everything over to the opposite side by doing its opposite.
Wait, why is 5a squared?
I'm sorry?
Why is 5a squared?
What's 5a squared?
The negative 5a. Oh, you're moving it. Okay.
Yeah, I'm moving it over to the opposite side. So I'm going to add 5a squared on this side, subtract 71a, and add 252. Okay. When we do that, the right side, everything gets canceled out. So all we're left with here is 0. On the left-hand side, we have 6a squared. Negative 5a plus negative 71a is negative 76a. Negative 14 plus 252 is positive 238. Okay. And now we have everything organized. Now we have this trinomial that we need to factor out. Okay. So before that, let's see if we can simplify anything. We know that 2 is a factor of all of these three terms here. So we could divide this left side and the whole equation by 2. 0 divided by 2 is still 0. This becomes 3a squared. This is 38. Yeah? Or minus 38? Minus 38a plus 238. Okay? So now, oh, I'm sorry. Thank you. Plus 119. All right?
Yeah.
Thank you. Okay, now we're at a point where we can use Xbox, okay? So use your Xbox. Just do a side Xbox. We got 3 and 3. A times C. It's going to be 3 times 119. Sorry, I'm going to use my calculator back here. 3 times 119 is 357. A times C, and your B is negative 38. What's that? No, there's only 6. But there's some review from before that are easy. So yeah, but I'm giving you time today to work in class too. So you'll have lots of time. They're smaller problems, okay? So on this example, you're going to have to figure it out. So I would just take the big number, 357, and start working it out. Your number is 38, right? So start thinking bigger, okay? I would start with 20. We know 20 doesn't go in. Try 19, 18. So I'm going to divide by 19. That doesn't work. 357 divided by 18 doesn't work. 357 divided by 17. Oh, look at that. Does that work? Check it out on your calculators, kids. What's 357 divided by 17? 21. Okay, good. So we know that 21 times 17 works. Now, what's 21 plus 17? 38. Okay, so we know we could use negative 21 and negative 17, okay? Xbox, finish this off. We can, right? So 3 goes into each of these, so it's going to be 1 and negative 7. Okay, now we factored this successfully. So we have A minus 7 times 3a minus 17. Okay, we're on the home stretch here. Zero product property now. A minus 7 is equal to 0, and 3a minus 17 is equal to 0. I'm going to skip some steps here. A is equal to 7, and A is equal to 17/3. Okay? These are your two solutions you figured out. Now, we're not done yet. Why not? We have to see if there's any extraneous solutions, right? This pen is a little thin. I'm going to thicken it just a tad. Okay. We need to check each of these to see if they're extraneous. If I put 7 back into my original equation, okay? So if instead of A, I'm putting 7. And what's 7 minus 7? 0. What happens if our denominator is 0? We can't have it. It's undefined. So since this answer makes it undefined, we don't use A is equal to 7. We call that an extraneous solution. That doesn't work. Okay? 17/3. You don't have to figure it out exactly, but we know 17/3 minus 7 is going to be a negative number, so it's going to be okay. So 17/3 is an okay solution to have. It doesn't make it undefined. You don't need to know exactly what it's equal to, but you know it's not 0. Okay? And that's it. So that's for number 1. Okay, I'm just doing this one example just to show you the steps. It does get a little bit bigger, okay? But you're applying concepts you already learned with factoring, right? And combining like terms. So at this point, I'm noticing you're all getting stronger at this stuff. So that's it. Any questions? Okay, so